0.1 RO as well as choked. They both are the same thing, right?
Yeah.
Okay, it is not a human dependent activity.
Yeah, that's what I want to mention. So that's why I mentioned the first point that there is no author dependency. That's why I just bring that point.
Yeah, this point is clear. Now you are saying no significant liquid carryover. How will you ensure no significant? Significant means what, and non-significant means what?
Yeah, actually that means like what we want to that exactly the ways we can cut off the significant and non-significant, right? So actually, what happens once the when the operation want to take this bullet for the depressurization, it is a manual depressurization. So they are transferring all the LPG from the one bullet to the another bullet, and whatever the residual liquid is there, they are again transferring it from the nitrogen purging to the bullet. So we are not seeing that almost 100% liquid is transferred, 0% liquid. There are some, we are not talking in the terms of the percentage or level, but we can say as a very minor volume, like I say as a 0.1 or 0.2 meter cube of the volume will be there in the bullet. That will again the pressurized through the nitrogen, and it will go to the via RO2 flame. That's why we can say it's a very less amount of or very residual liquid can go to the
Okay. So if this 1 meter cube or 2 meter cube LPG liquid will go to the flare, will this impact the flare operation?
Not 1 meter, even we can say it's a 0.1 to 0.2. And actually what happened, the KOD is there. And this operation, we can say this is not a continuous operation. We can say this is a cyclic operation. So we can do the injection, we can depressurize, we can inject, we can depressurize. So this is a controlled operation, controlled manual operation.
Okay, I think Hanner is raising the hand. Yes, Hanner.
Yes, to add to what Kedar explains, we will have this minimum or traces amounts of liquid that we also expect to be flashing as we open the pressure to the flare header, because of course that's LPG. So once you reach the vapor, so we have virtually no liquids is what we expect.
Okay, so now question to Kedar, since he is the process designer. Kedar, I mean, after the RO, will there be any jetty effect?
No, because normally as also there, because what happened, the pressure is very less. So what happened, the LPG is also going to convert into the vapor mostly, because we are going to the atmospheric pressure. And normally at around 500 kPa or 400 kPa, LPG is not into liquid format, is going to into the vapor format. That is one thing. And what is your question that there is we're not seeing that much of the any JT effect, or we can say as a minimum temperature down to the discharge of the RO if you are having the very less amount of the LPG. So we are into the limit of that carbon steel like a minus 29 degrees Celsius or that.
Okay, MD you have taken, right? When you started design minimum temperature, you have taken.
I think you want to ask that same question like that. So the temperature is also within that limit of that minus 29.
Okay, and the discharge of the RO has been designed to minus 29 degrees Celsius.
Yeah, because its material is a A2CS carbon steel piping class is there. So the temperature almost for the carbon steel is a minus 29 degrees Celsius.
Okay, very good, very good. Okay, so these are the design bases. So guys, the simple questions are very important, because this will be the design basis for our HAZOP. So Kedar, thank you very much for explaining this. So Kedar, can you share this PPT? I will put this design basis in the HAZOP sheet, so that people will refer this design basis when they are referring the HAZOP. Right, Kedar?
Okay, I'll send.
Yeah, sure. So guys, any question from entire team? Scott, Hanner, or anybody, Sylvester?
No, nothing from my side.